Hello everyone, our project title is Automated Table Tennis Analysis System. Here is an overview to our project. We'll work on speeding up the process of labeling for ball placement within table tennis matches, and therefore, we implemented an automated ball placement detection system and improved a platform which is developed by our lab. This platform can label and visualize sports matches. I'll start with our platform, Athena. This platform is developed to help user label and visualize data of a certain sport matches easily. And the sport that we're working with in this project is the table tennis. This is our labeling page. The user can label match data here, such as serve, action, placement, etc. In this project, our main concern is how slow it is to label one single ball placement. To label a ball placement, the user needs to watch the video manually and maybe do some adjustment and find the correct frame where the ball placement has happened. And in this case, we'll just mark where the ball has landed and do the add event function. And by doing so, the event will be added to our database. But for example, in this sample batch, there are up to 517 ball placement, and manually marking all of them is not only a waste of time, but also a waste of human resource. Therefore, we try to automate the labeling process. Here, our temporary implementation is by generating a ball placement label file generated externally, and we can upload it to our system here. Now, let's look into how the ball placement detection works. Intuitively, the ball placements can be detected by looking at the change of ball's direction. But broadcast video are often shot from some distance, and these change of direction may appear very subtle. And we can't really assume that the ball will be caught by the camera clearly, and the changes of direction might be blurry. We use this blurry to our advantage and developed a method to find the ball placement from its distorted shape. Here are the rules that we set in order to get the ball's placement. We try to find a V shape from one single frame or a change of slope in two consecutive frames, and there can be these four kinds of cases that marks for a placement. To do so, we split our process into four steps: scene detection, ball detection, hit timing detection, and placement detection. First, we use the histogram detector of PyScene Detect to detect the scene change and cut the entire broadcast videos into shorter clips. Then using ResNet 18 model, we can further classify each clip as either a side view clip or other types. On each of the side view clip, YOLO V8 is applied to obtain the ball's position and shape. And here, for every 5 consecutive frames, we use a sliding window to check the x coordinate. Once we find the minimum or maximum x value at the middle frame, like the third frame in this case, we will identify this middle frame as a hit timing, or the moment a player hits the ball. Last but not least, in between two hit timings, we can find the ball placements by using the 4 case that we mentioned previously. Now, for the evaluation part of the ball placement detection, we label a match data that consists of 91 rallies and 439 ball placement timings. Here, we consider a case to be a true positive if the difference between the predicted timing and the ground truth is within one frame. And let's go on to the next step. Our ball placement detection will return us a 2D point with respect to the broadcast video itself. We need to transform that point to an actual point on the table. And to visualize it clearly, this perspective needs to be a top view perspective on the table. To do so, we need homography. In homography, we need to first find the source points that we want to transform from, in this case, the 4 corners of the table. Following that, we need to have a destination point, which is the perspective that we want to transform into. By using the source and destination points, we can obtain the homography matrix. And given the coordinate from the ball placement detection, we can do a perspective transform on the ball and get a relative position on the table. After labeling the matches, the data can then be visualized in our visualization page. Here, we can select a certain player and find a match that player has participated in. And it will show us all of the data within this match. Since everyone's preferences are different, for each type of data, the user can choose what kind of chart do they want to visualize it in. And for example, in the case of ball placement labeling, the most intuitive chart is this kind of heat map chart. In the future, we would love to provide even more chart options for Cortina so that the users can have more options to choose from, and we'll implement more automation models such as removing the need of labeling the table corners manually, auto action recognition, etc., so that we can label more matches faster. And that is all for our project. Thank you.